Hello and welcome to Class Time, students. You can watch us live every weekday from 9 to 10 a.m. on TVJ and on onespotmedia.com.
You can also tune into the School Time channel also on onespotmedia.com.
And you can also keep up with us on our various social media platforms and use the hashtag to make queries or answer online questions.
I'm Nikisha Bailey.
And I'm Nikisha Hardy. We'll be guiding you through today's mathematics lesson. So let's begin. Today we'll be looking at trigonometry and geometry through problem solving.
All right, so we have some tips that we want to give you. You would have heard this along the other sessions. So what are some strategies that we use? So the very famous one, guessing.
So this includes guess and check, where you guess or you improve, and then you can either act it out or use some equipment to help you as well.
Drawing also helps.
Yes, I'm a visual learner, so when I draw, it helps me to see what the question is asking.
We could also make a list.
Or a table.
Right.
Yes. And this also, and then we have to think. So this includes using some skills that you know already, some concepts, some contents.
Right.
You'll be drawing on previous knowledge to help you here as you think through the problem.
Okay. So obviously when we're looking at the question, if there's a problem, then the problem needs to have a solution, right?
Right. So sometimes the questions may be written in words or using numbers and variables.
Still a problem, not true.
Right.
Whether words or numbers, still a problem.
A question, they're right for you. And know the answer. When you get to your answer, so you'd have to make sure you write your answer, because sometimes we keep the answer in our head and forget to write it on paper.
And not just writing, but we have to check.
Check the math.
Right.
Yes, to ensure that it makes sense.
So when we check in, we have to say, does this make sense?
Yes. So in explaining your reason, you're saying this is so because so and so.
Right.
All right? And then, as you said, does it make sense? And one way we can check to see if it makes sense, Nikisha, is to substitute our answer in the problem, in the working, going out. We can work backwards.
That is right.
Yes. Now, as we said earlier, we're looking at trigonometry and geometry. So
we are going to be looking at Pythagoras' theorem. We're going to be looking at the trig ratios.
So the trig deals with the right angle triangle, the right triangle, right?
Also we'll look at the right triangle.
So let's examine it, just to refresh our memories.
So what is the right triangle? So first thing that comes to mind, right angle.
Yes.
So there must be a right angle.
That measures
90 degrees.
Yes.
And we all know the triangle has
three sides.
So the side opposite to the right angle we know as the hypotenuse side, and the other two sides, other two sides.
Yes.
We call them the sides, but they have specific names that we will look at.
Depending on the angle.
Right.
That we're examining. All right.
So, as we said, these are the three areas that we're going to be focusing on.
So we're going to be looking at, go back a little. So we're going to be looking at the naming of the sides, just to review, naming of the sides of the right triangle, the trigonometric ratios, and the Pythagoras' theorem.
Okay, so naming the right triangle. So we just mentioned that the side opposite to the right angle is known as the hypotenuse side. And as Nikisha said earlier, depending on the location of the angle, we're able to name the other two sides.
Yes, in relation to the angle. So if the angle is here at this point as been shown on the screen, the other two sides in relation to the angle, this side would be opposite to the angle and this side would be adjacent, meaning beside. So this length here, this side is beside this angle, and this side here is opposite or facing the angle.
And you know, we should also note that the opposite and the adjacent side, these sides actually are perpendicular.
Right, so that's where we get the right angle right there.
So if we change the location of the angle,
Okay, so it's no longer here, but the hypotenuse, I notice,
remains the same.
which is always across from the
opposite the
right angle. And another thing to note about the hypotenuse in terms of Pythagoras' theorem, it's the longest side of the right triangle. So notice now the angle is here at the top. This angle, in relation to this angle, this side now is opposite to that angle. And now we have this side now being adjacent or beside this angle in question.
All right, so as per usual, let's check and see what you know based on our discussion earlier.
So the first triangle, notice in relation to angle 35, the angle measuring 35 degrees. Before we get there, so we start from the hypotenuse because that's easy to identify.
So that would once you can spot the right angle, then you can spot the hypotenuse side.
Right across, and that line segment would be QR.
Persons might say RQ. Would they be wrong?
They wouldn't be wrong, but we usually try to keep the naming of the sides in alphabetical order.
All right. No. So the hypotenuse is QR.
Right. So adjacent, so in relation to angle 35, which side would be adjacent beside angle 35?
So you know what they can do?
Yes.
They can easily say, all right, they can spot the opposite side. So the adjacent side would be the other side, right?
Right.
So in this case, our adjacent side is going to be PQ. And the opposite
would definitely be PR.
PR.
So the opposite is the angle that's facing the angle in question, the side that is facing the angle in question, PR.
All right, so let's look at number 2. So for those of you at home, think about it, and we're going to show you the answers and let's see if you get it correct. So the hypotenuse side in this case.
Yes.
This one looks different. The triangle, the orientation has changed, but same right angle triangle, right?
Just find the right angle, then we'll get the hypotenuse.
So the hypotenuse here would be
5.2 centimeters.
All right. The adjacent side is going to be?
Adjacent to 43, the angle 43 degrees would be X, side X.
So obviously the opposite side is going to be?
3.4 centimeters.
All right.
Yes, that's the side facing the angle.
And for third question, hypotenuse side?
Right across from our right angle, which would be 8
centimeters. The adjacent is?
To angle Y.
Right.
Would be 6.6 centimeters, the side measuring 6.6.
And the opposite side is going to be?
P.
Awesome.
So once you're able to name the sides of the triangle, the right triangle, in relation to the angle that we're talking about, then we'll be able to use the, to choose the trigonometric ratio.
All right, so we just spoke about the trig ratios. So what exactly are these trig ratios?
So these are functions of angle that compares two sides, and the ratio of the sides of a right angle triangle with respect to any acute angles. And we talk about acute angles.
So we must highlight that these are actually acute angles.
Yes.
So beside, apart from the right angle, the other two angles would be
less than 90 degrees.
Right, acute angles.
Right. So, and we know the three most common trigonometric ratios are sine, abbreviated SIN.
So the sine,
cosine, COS, and tangent, tan.
So when we talk about sine, we're actually comparing the opposite and the hypotenuse sides of the triangle.
So we're looking at those two.
So cosine of the angle is a comparison
of this adjacent side and the hypotenuse.
And the tangent
would be the opposite side and the adjacent side, a comparison of those two sides.
So we're talking about the ratios.
The ratios here, yes.
All right. So when do we use, how do I pronounce this word? I don't know this word. What is this word?
Actually, it's not a word, it's an acronym.
Okay.
SOCATOR, to help us to remember the trig ratios. So shortened form, we have SOH, S for sine, O for opposite. So these two second letters telling us the sides. So the first letter is for the name of the
trig
ratio.
Okay.
And these two, O and H, would be the sides that we're comparing. So opposite and hypotenuse.
Okay, so CAH.
So
cosine,
C would be for cosine, the ratio cosine.
and it deals with the adjacent side
And
and,
the
the hypotenuse.
So T would be for tangent, and then we're comparing the opposite side and the adjacent side. So we must be a right angle triangle for us to use the trig ratios. All right? And you must also have two sides and an angle, or any two thing that is there. Once you have two sides and an angle, or two sides and one is missing. Two of the quantities given and one of them is missing.
And as you mentioned earlier, the hypotenuse side is the key. Once you can spot the hypotenuse side, then
yes,
you're good.
Which is across from the right angle.
So then we check where the angle is located, and then we can assign the title opposite and adjacent based on the...
So based on what this is saying here, so two quantities given, so we can be given two sides of the right angle triangle, and we can find the angle using a trig ratio.
Right.
Okay.
Okay, so let's do something here. So which of the following ratios is true for this triangle? So these are our options.
All right. So based on what we know, sine theta would be the opposite side divided by the hypotenuse.
Or the ratio of the opposite to the hypotenuse.
And in this case, I'm seeing 3 centimeters. Yes, it's opposite to the angle. However, my hypotenuse across from the right angle is 8.5 centimeters.
So
and this
first
is 8.
one is out.
That's out. So that means we can't use sine for this.
All right. So that one is not true.
No.
So tan theta. So tan, we're comparing the opposite and the adjacent side.
Mm-hmm.
So if my angle is theta, the opposite side is 3 centimeters.
Yes.
And I realize that all of these, they have 3 centimeters at the top
in
of
the numerator.
Right. Mm-hmm. So it works. So that's the opposite side.
Yes.
But then we want the adjacent side. Is the adjacent side actually 8 centimeters?
Adjacent to
the angle theta.
The angle theta. Yes, 8 centimeters is adjacent.
All
Why
right.
couldn't it be cosine?
All right, so cosine, you're comparing the adjacent. And clearly, as I said earlier, the 3 centimeters represents the opposite side.
In this case, yes.
All right,
so it would be 3 centimeters opposite and the hypotenuse for cosine. And the hypotenuse is 8.5, while we are seeing here.
So the statement that's true, or the ratio that's true, would be tan theta is equal to 3 centimeters
divided by 8 centimeters.
All right. So here's our second one. So we kind of switch it up a bit for you because we don't want you to think that the right angle triangle is always going to be that perfect looking.
In that orientation at all
that we're always seeing, you know.
So as we realize now, so our right angle, so we can identify our hypotenuse right across from our right angle.
Very first thing to identify.
Yes, and we are looking at theta here. So opposite to theta, we have side 4 centimeters.
4 meters.
4 meters,
right.
Thank you. And adjacent to the angle is 8 meters.
8 meters. Mm-hmm. All right, so if we know that sine theta, we're comparing the opposite side and the hypotenuse side. So clearly the opposite
sine
is wrong.
Yes, 8 meters is not opposite to the angle.
So we can eliminate that one.
Yes.
What about tan theta?
Tan theta. So with tan, we're looking at
opposite again. So clearly this one is also wrong.
Yes, so we can't be tan.
So using elimination,
yes,
we would say, all right, cosine. But let's just check to make sure that it's actually correct. Right. So the cosine of theta would be
we're adjacent with the
So the adjacent side here is 8 meters. And the hypotenuse is 8.9 meters. So that would be the correct statement.
Yes.
And I think we have one more here.
In or right angle, in a triangle in a different orientation. Awesome.
So again, where is the hypotenuse side?
Find the right angle and then look across from that.
All right.
So here is our right angle, so it means or hypotenuse. And we notice that the hypotenuse, the length is always the high, the longest.
Right.
Right. So it's 12 millimeters.
So the hypotenuse is 12 millimeters. So I'm going to just switch it up a bit here, Nikisha.
All right.
So sine theta, the hypotenuse, so the denominator in this, or the but should be 12 millimeters. So sine is, that statement would not be true.
Right, because sine is comparing the opposite and the hypotenuse.
All right.
Yeah.
So let me skip down to the bottom one now.
All right, this sine.
So the denominator in this case is 12 millimeters.
Yeah.
So it seems correct.
Seems
so
correct.
let's just check and see if the opposite side is actually 4.8 millimeters.
Actually, yes, it is.
All right.
4.8 millimeters.
And why couldn't we use the middle one now?
Tangent. So this angle we're comparing what? With tangent we're comparing the opposite and the adjacent side
so
to
the
the angle.
tangent is not really linked to the
No,
hypotenuse side. So the 12 there is the giveaway. So the 12 cannot
the 12,
be there.
right, because we're looking at adjacent and opposite.
Right.
All right, so that's how that would help us.
So the
see.
correct statement there, or the correct ratio, would be that sine theta is equal to
4.8 millimeters divided by 12 millimeters.
all right.
So we're going to be looking at how we can use these trig ratios to help us to solve problems. So we're going to apply these ratios to some real-life problems. And remember, we choose the easiest ratio to use based on what information that you are given
in the problem. All right, so here's a little diagram to help you along. So is the triangle a right angle triangle?
Right, so when you're looking at your problem, see after you've made your sketch then. So, right, so if it is a right angle triangle, yes, we would do what?
So does it involve any angles?
If yes.
If yes, then we use the trig ratio, so we know sine, cosine, and tangent. But if not,
we use the
it means that
Pythagoras
we're going to be moving to Pythagoras' theorem.
Once it's a right angle triangle.
But if it's not a right angle triangle, what do we do?
All right, so it's not a right angle triangle. Do you know a side and its opposite angle?
If you do,
use the sine rule.
And we'll look at that later on.
Yes.
And
if
not,
you use the cosine rule.
All right.
So you look for a side in the right angle triangle and its opposite angle.
All right. So let's see what comes next.
So the sine rule. So let's look at the sine rule, the cosine rule, and the trig ratios in summary.
All right. So here we have it. So as we said, you can always draw a picture.
Right.
And figure out or decide which formula you're going to be using.
Yes.
And then you're going to solve the problem that you're given. So here we have 4 such
methods that you could use based on what you're given. And thinking about the chart that we just looked at, so we would, as it says, right angle triangle, have an angle. So this is basically summarizing what we just looked at in the previous.
So we have the SOHCAHTOA.
Yes. We have the laws
of sine
and the law of cosine and side angle side for finding the area of a triangle.
All right, so we'll look at the law of sine. So we can say that if we have 2 known sides and an angle,
right,
then it depends on the location of these, right? The angle and the length.
As it says, the opposite. If you know a side and its opposite angle, then you would use that. And if you also know 2 angles and a side, so what a 2 is given, plus a side, 2 angles on a side, 2 sides and an angle.
All right. And similar for the law of cosine. So you're actually looking for certain details to decide on if you're going to be using this formula or not.
Or the trig ratios, which is one of the trig ratios.
And we will actually see how we apply these formulas when we move on in the lesson. And the area of a triangle. Somebody's seen that. What means a half base times height?
All right. So it depends on, yes, half base times height. But as it says here, you have a side. If you have 2 sides and an included angle, you can use this.
And you know, for me, right away, if I'm asked to find the area of a triangle and it's not a right triangle, I'm going straight to this formula.
Because, right, because this one would work for that as well.
All right. So first up, the Pythagorean theorem, or some persons say Pythagoras theorem. So what does it state? So this should be known already.
The side opposite the right angle is the hypotenuse,
And as Nikisha said, it's always the longest side.
and that's usually labeled as C.
Well, in our case, we're going to call it C.
C in this case. Yes, it can be anything.
So what does this theorem state, Nikisha?
Well, what I'm seeing here is that the sum of the square of this side and this side, side A and side B, the square, sum them, we'll get the square of the hypotenuse.
And you know, students actually draw the squares on the side, so you'll be able to prove
Right.
the theorem. All right, so we're going to be solving a question using Pythagoras theorem. So here we have a problem.
Okay, so we have two hikers leave a cabin at the same time. One heading due south and the other headed due west. After 1 hour, the hiker walking south has covered 2.8 miles, and the hiker walking west has covered 3.1 miles. At that moment, what is the shortest distance between the two hikers?
All right, so Nikisha, give me the key details that we need to work this one out.
All right, so let's draw a picture. I think we should, so many
Yes.
words, let's put it a picture to it.
All right.
All right, so the two hikers live in a cabin.
So I need a cabin.
Yes.
Do I actually draw my cabin?
No, we can just draw. We
All
don't
right,
have
I'm
to.
going to put a little. That is my cabin.
So it said one of them head south.
All right, so first thing, I'm not so sure about direction. So
Let's draw our cardinal point.
So how is it now? North, south, east, and then
west.
All right.
All right.
So something looking like that?
Definitely. That's familiar.
All right, so now give me the directions.
All
now.
right, so one is heading south from the
So,
cabin.
One is going to be going this direction.
Yes. And the other is going west from the cabin.
So west
Yes.
would be this direction.
All right, so the one of the hiker walking south has covered 2.8 miles.
All right, so I'm going to be labeling this 2.8. Can I write MI for miles or do I write out miles?
And
All
the
right, it's
other
pretty short. So I could
3.1
All right,
miles.
so 3.1.
All right, so
All right.
at that moment, what is the shortest distance between the two hikers?
So if one hiker is here, one is here, shortest distance. We Jamaicans love take shortcut, not
Yeah,
true? So I'm not going to be going all the way here. So I cut across here, so not true.
Right, I'm thinking
Shortcut.
about vectors right here.
All right, so this might not be perfect, but
So we have a
at
triangle.
least you have a sketch.
We have a triangle.
Right.
Yes, and
So
a right
and the hypotenuse side would
be opposite
opposite the
right angle.
right angle. So this would be the right angle.
Okay, so we have two sides, and we're trying to find another side.
So based on what we
Pythagoras'
said about
theorem.
the theorem,
Yes.
so
Let's write the formula.
all right. So I'm going to be using the actual. All right. So the hypotenuse. Am I going to be using the one that we showed
Yes,
earlier?
yes.
All right. So c squared is a squared plus b squared.
Yes.
So we said that c squared.
That's
the
what we're
c
trying to
represents
find.
the hypotenuse.
Yes.
And a and b would be the other two sides.
sides.
So we can assign a to
Either.
any and b to the other.
Yes.
All right. So what we would have c squared is equal to, if I call this one a,
3.1
so
squared.
3.1,
Squared.
and we're going to be squaring this. We're going to put back the units afterwards.
Yes.
And this one would be
2.8.
2.8 squared.
Yes.
And of course, you would need to have your calculators
Calculator.
to work this one out.
Yes.
So let's see what the working is actually going to look like.
So this is a picture of what we
All
have
right,
there.
so not bad, right?
No.
Okay, so the unknown is the hypotenuse, as we said. So here we have it. So when we actually do this,
The square of,
when we find all this is 17.45 miles squared. So the shortest distance here would be 4.2 miles, and this is to 2 decimal places.
All right, we're going to come back to this question because we're going to take a quick break and we'll be back with more mathematics.
Welcome back. Let's continue with the lesson. So Nikisha, before the break, we were looking at this question. So here we have our good up diagram, unlike mine.
Well, yours is good. Yours is good, acceptable. It's
All
clear.
right.
All right, so let's see the working of how we would find the hypotenuse, the shortest distance between the two sides.
So as we had
So when we
here,
would have squared 3.1 and also squared 2.8,
would have gotten 9.61 meters, miles squared, and 7.84
square miles. Yes.
Right, thank you. All right, so finding the sum of these would have gotten
17.45 squared miles. And that would be for x squared.
Right, so if we want x,
right,
we're doing the reverse operation of squared, which is to find the
square root.
Square root. So we find the square root of this value. What do we get?
4.2 miles. So that would be the shortest distance between hiker 1 and hiker 2.
And, you know, we actually did some approximation right there. We did some rounding up.
Yes.
So this is to 2 decimal places.
One. All right.
Well, it's actually 1.
Yes. All right. So that would be that applying Pythagoras' theorem here to this problem.
All right. So what do we have next?
All right. So depression and elevation.
Angles of depression, elevation, depression.
Going down and elevation up. All right. So you would have covered that topic before in previous lesson. So we're just applying some problem solving skills to solving questions of that nature. So we have a ship's sonar located at treasure chest at 12 degrees angle of depression. So a diver is lowered 40 meters to the ocean floor. We want to know how far does a diver need to swim along the ocean floor to get to the treasure chest. So there is the ship underwater, and its sonar has picked up a treasure chest that is at a depression, an angle of depression of 12 degrees. And they have lowered. So let's draw this.
All right, so what's the first thing I'm going to be drawing now? So
we can draw the ship on the water, on the sea.
All right.
Yeah.
So here's my ugly little boat right there. It's supposed to be a ship, but
it's
a drum
on the sea, right?
All right, so.
And since we're talking about depression, so it means that we're going down. That probably will have to stay.
All right, so.
So it's our angle going down. So the sea level
so
would be our horizontal.
All right.
Yes.
So this is the horizontal. What do I have next?
Angle of depression and our diver.
So angle of depression, how would I draw that one?
All right. First, let's lower the diver 40 meters down from the ship.
So the diver is going to be here?
Yes.
All right, so I think I drew my ship too low. So here's a...
Draw a line connecting the ship.
All right, so we have a line here.
And that's 40 meters.
And this is supposed to be 40 meters, all right.
And the treasure chest is 12 degrees depression.
So if this is my...
Your sea level.
Sea level. Her chest is going to be where? Over here? Or on this side?
On this side.
All right, so my chest is going to be here.
Yes.
Something looking like that. Whoa.
So let's put in our angle.
And where would I have my angle now? So it means I'm going to be doing some connection here, but where would I have my angle?
It would be between the...
Here?
Yes, sea level.
All right. So because it said angle of depression and it's given as
12 degrees.
12 degrees. So something looking like this.
So we want to find the distance that the diver would swim towards the treasure chest, right?
So this
along
is
the ocean
the
floor.
unknown.
Right.
So I'm going to call this, I don't want to write X, I'm going to write P.
No, what? So that's what we want to find. All right, so I'm picking up right here an alternate angle. So right where the treasure chest would be would also be 12.
Okay, so you know they also call it the Z angle. So it's just
Yes.
like a back way.
That's a Z, yeah.
Right.
Yeah.
So whatever the size of this angle is here,
It would be
then
the
it's
same.
also going to be the same here. So it's also going to be
12 degrees.
12.
Yes.
And it's actually 12 degrees. So it makes, to me, it makes more sense because now I have the angle within the triangle that I want to focus on.
Within the triangle.
Right.
All right. So you have an angle and you're given a side and you want to find a side. So which ratio could we use?
All right. Do we have enough information here? Yes, we do. So this would be the right angle right there.
Yes.
So I have my right triangle.
Yes.
So hypotenuse side would be here.
Opposite. HYP, yeah.
So if my angle,
12 degrees.
so this would be my
Opposite.
opposite. So this would be
Adjacent.
the adjacent.
Awesome.
So based on what we're given, so we have the given angle, we have the opposite side, and we are interested in finding the adjacent side. So opposite adjacent, soka tower.
That sounds like
OA.
tangent.
Tangent,
Yes.
all right.
All
So let's see what we have.
All right, so we're saying tangent of 12 degrees is equal to the ratio 40 divided by x, opposite by the adjacent side. So doing some inverse operation, we would multiply both sides by x, and now we'd have isolated 40, but we want to isolate x.
So we're dividing both sides by
tan 12.
tan 12 degrees.
Right.
So when we actually work this out, and of course you're going to be using your calculators,
Yes.
then the value
length
of x, meaning the distance between the diver,
and the treasure chest,
it would be
188 meters.
all right.
And that would be the length of that side. So, awesome. Pythagoras' trigonometric ratio.
So
here.
this one we're using the tangent. We're using.
Yes, trig ratio helping
All
us
right.
here.
So here is another question.
So farmer Joe, where you needs to fence his triangular plot of land for his cows. So this man has a triangular plot of land. Now the angle between the two sides measure 83 degrees. One side is 122 feet and the other side is 215 feet. So we're given two sides and an included angle, because it says the angle between the two sides
Okay.
measures 83 degrees. So,
All right. So how do I draw this plot of land?
it's a triangle.
Can I tell if it's a right triangle or just...
All right, no, it didn't really say if it is a right triangle. It just tells us that two sides, it just gives us the angle between the two sides. So let's establish that, and then we can join and see if we get that.
All right, do you want us to look at the given diagram, or do you want us to draw?
All right, let's look at the given diagram, because maybe it will take up less
right.
time for real.
So here's what the diagram looks like. So
As it said before, we had 83 degrees between two sides, and we want to find the length of this side. So based on what we have discussed before, two sides and an included angle. All right?
all right, so, and I'm seeing based on this diagram, it's not a right triangle.
No.
So therefore, we can't use
The trig ratios.
All right, so what do we use?
We could use the sine rule.
All right.
We could use the sine rule, yeah.
All right, so let's see. The question says, how much fencing does Farmer Joe need
To
the nearest foot?
Right. For here, x. So let's do the working.
And it also asks for the area of the plot of land.
Okay.
So,
Oh, it's a cosine rule. Like,
all right.
yes. with the included angle, sine or cosine.
All right, so we're basically applying the formula. Want to take us through this one, Nikisha?
All right, so based on the cosine rule, we see that we for the two sides, A and B, and we have our angle here. So we would substitute the two sides given, square them, and subtract 2 times the product of the two sides times cos 83.
And you know what I realized also, Nikisha? That the missing side is connected somehow to the angle.
Yes.
So the missing side is opposite to the given angle.
To the given angle,
all right.
Yes. All right, so simplifying what we have in the first line, that would give us that x squared would be equal to 54,715.73.
Okay, and of course, we're doing the reverse operation to find the value of x.
Yes.
So x here would be?
The square root of that, which would give 234 feet.
So let's put that on the diagram. And then the question asked us, we needed some more information, right? So the total fencing.
So we'd find the perimeter.
Perimeter.
Right.
And as they would say, you're just adding up everything.
All the sides.
All the sides. So 122 feet plus 215 feet plus 234 feet. So there we have a total of 571 feet. And then the final part of our question, it asked us for
the area.
Area.
Yes.
No.
Half base times height.
This don't look like right triangle, so
half base times height
is just not going to cut it. All right, so we have to use that other formula to find the area of
where we have two sides and an included angle, right?
So here we have it.
So half the product of the two sides times the included angle. And that would give us, after simplifying that, would give us an area of 13,017 feet.
Square feet. All right.
So that's that.
So now to the sine rule. So here we have a question. So we have two girls.
All right, before you read a question and then before you solve it.
All right. So Ali and Brianna, they are standing 250 meters apart. Both girls sight an airplane with angle of elevation 40 degrees and 45 degrees respectively. How far from the plane is Ali?
All right. Now, before you go any further, let us differentiate the sine rule when we use the sine rule and the cosine rule.
All right. Do you want me to sketch that diagram first?
No, not just a second.
Okay.
Just looking at the question, previously we were given two sides and an angle, an included angle.
Right.
And in this case, we're given two angles and a side. All right?
Okay.
So previously, we used the cosine rule when we're given the two sides and an included angle.
Okay.
And this one here, this situation calls for the sine rule. We're given two angles and a side.
All right.
So we can sketch quickly.
I'm going to do a quick sketch. So I'm going to just write A and B for Ali.
Yes.
So Ali and Brianna, they're standing
250 meters apart.
250 meters apart. So they're looking at a plane.
Yes, elevation.
So I'm just going to write plane. I'm not going to attempt to draw it.
No, please. So one 40 degrees and the other 45
So Ali is first. So Ali.
Yes.
So this would be
40 degrees.
40 degrees.
And 45
Brianna
degrees.
Looking up at the plane. This is going to be
45 degrees.
45 degrees.
And you're asking how far from the plane is Ali?
So we want to find this distance. I'm going to call this one Y. I don't like using X all the time.
No problem. No problem.
All right. So you say that we're using the sine rule.
Yes.
All right. So based on my recollection, the sine rule now, which one?
We can put the two angles on top.
So we're comparing the angle to the
side. The opposite side.
All right. So if I'm using, so which one are we going to be using here?
We can use...
Let me write this properly. So this is 45.
Okay.
All right. So obviously we're going to be looking at These two?
Yes. We want to
So,
find that one.
this one, so sine 45 degrees, and I'm comparing it or finding
Yes, yes.
the link with the y. But what's the missing one?
We want to find
No, look at this. The 40 degrees, I don't know this side
No,
here,
no,
but
but I
this
know
one, but we can find this missing angle.
Yes.
So the
Based on
angles
what we
in
know,
a triangle add up to
180 degrees.
All right, so we would add the 40 degrees and the 45 degrees to get 85 degrees.
Yes, subtracting that from 180.
From 180. So this would give us, what value would we have here?
Well,
So
95.
95. Make sure it right, you know.
We calculated it.
Because I'm not checking this one. But let us see.
All right.
So I hope it's right. All right, so this one would be sine and
250.
Sorry, 250. So let me see if you're right because I'm not checking. So
Let's see.
let's look at the solution. Okay.
Third angle,
I'm going to give you a
95.
tip for that one.
Okay.
All right, so the missing angle there would be 95 degrees. So using the...
Sine rule.
All right, so
Yeah,
same thing, but in...
different. It doesn't matter which one comes first.
All right, so we're doing a comparison. So...
All right, so we can simplify. And in simplifying, we would find that the distance from alley to the plane would be 177.45 meters using the sine rule here.
All right, not bad.
No.
And
All
the beauty about it, you're given the formula.
Yes. So you just have to choose the easiest and the most appropriate one based on the information that you're given.
Right.
All right.
Okay, so geometry.
Yeah.
All right, not bad.
All right, so
All right, so before we actually go into geometry, we're going to take a quick break. We'll wrap things up when we return.
welcome back to class time. Let's continue.
So, but Nikisha, before we went to the break, we started geometry, or we were about to start geometry.
All right.
So,
let's see how we can use some algebra to help us to solve some geometric problems.
so this one is on perimeter. So a triangle has a perimeter of 50 units, and if two of its sides are equal, and the third side is 5 more than the equal sides, what is the length of the third side?
Just draw for me, please.
All right, so triangle.
Triangle.
Looks like this.
Yes.
Two sides are equal.
Two sides are
But we don't
equal.
know what these sides
So
are.
assign some values, some variables.
All right, so I'm going to use x.
All right.
So these two, and this triangle will be what? Two sides are equal.
Ah,
The isosceles. So two sides are equal, and the third one
side
is what?
5 more,
5 more
than the
So-
equal side. So we add in.
So 5 more.
So
So,
it's x plus 5 more. Yes.
All right.
Okay.
So what is the length of the third side? I will also know what the perimeter.
Oh yes, 50 units.
Perimeter, 50 units.
Okay.
All right. So let me see my diagram.
So we have
So
assigned
we
variables.
have done that. Sketch.
We have sketched, yes.
All right. So we're on point.
Awesome.
So how do we find the perimeter of a triangle?
Okay, so perimeter is the total distance around the figure.
Right.
So it therefore means that we would add or
So I'm going to use P for perimeter.
Go, yes.
So we're adding all the sides. So let me start here and go.
Since you have the perimeter as 50, we could just write
All
50.
right, that's good. So I'm going to ignore the units
Yeah,
for
oh,
now.
yes.
So 50, the
So we have
perimeter.
x, one side is x,
So we have x, and
plus
we're adding
another
x.
plus,
And we're adding, I'm going to put this one in brackets, and then we
okay.
can remove the brackets after.
All right. All right.
So removing the brackets, we would have,
We can simplify. So we'd have,
all right, so I'm giving myself work here.
yes, a lot
so
of work. Three
I'm seeing,
x's.
so 3 x's.
So 3x, 50 is equal to 3x plus 5.
Plus 5. And this one, solving a simple linear equation.
All right, so we just to do some inverse operation, subtract 5 from both sides.
So that would give us what?
45.
And then we would have to
Isolate x by dividing by 3. So we divide both sides by 3.
So we would divide both sides by 3.
So
and x would give us
15. 45 divided by 3.
All right.
15.
So there we have it. These are the steps that we would take. We have done this already. All my hard work here.
Right, but we just use being efficient, all right?
Right. So as we said, x is 15. And because we weren't given any real units, so we would say that the missing side would be 15 units.
Yes.
All right. So we had some more questions here. We're just going to skip.
Let's down to the
We're going to skip through these. And we're going to go down to this one.
All right. So we're looking at problems with algebra. So in a quadrilateral, 2 angles are equal. So quadrilateral, 4-sided figure. All right, so we're going to make a sketch. So the third angle is equal to the sum of the 2 equal angles. So quadrilateral.
So quadrilateral.
4-sided figure.
Any random, can just draw any random.
Quadrilateral.
All right.
All right. Yeah.
So suppose I did something like this.
No problem.
Would that work?
No problem.
But then
But it would be based on the information. It says the 2 angles are equal.
the third
angle is equal to the sum of
the
2 equal angles.
and the
Fourth angle is 60 less than twice.
Whoa, that's a whole heap of information.
That is a whole heap of information.
You know what? I'm going to run away from this one. Let me see what the diagram looks like. All right, but nevertheless, so we're given the information and it says find the measures of the angles in
the quadrilateral. So
All
we
right.
just need to just assign variables and then let x be the side of one of the 2 equal angles.
All right. So with that being said,
All right, let's look to see if what we have here in our diagram
matches the information that we're given.
So we have 3 minutes left. So 2 angles are equal. So here they are, x and x, they are equal. And the third angle is the sum of the equal. So that's why we have x plus x for the third angle.
And the
fourth angle, 60 less than twice, as this 2 would suggest.
The sum of all
the sum of the other 3 angles.
All right. So
we're going to now write down the sum of the quadrilaterals, and the sum of the angles in a quadrilateral is 360. So we're going to equal all of that.
So let me just go back there. So
No, we don't. So let's just do it on the screen here
All
because
right.
time is going against us. So substituting the angle size, equaling them to
360, which is a total
of the angles in a quadrilateral, then we would just simplify by combining like terms, remove this bracket here, simplify what's inside the bracket, then remove the bracket.
And we can actually prove it. So we have the 4x right there.
1, 2, 3,
and
4.
And then we have 2 times the
4x is here, right
and
here.
we're subtracting 60.
Here
So
we can further
simplifying.
simplify. 4x, 2 times 4 give us 8.
So we have 8x there. And we can simplify again. So 4x and 8x would give us
12x.
And using reverse operations, we would actually be adding 60 to both sides to get 420 is equal to 12x.
Right.
and then we would again do reverse operations. So here's what we would have. So x would be equal to 35.
But remember
So,
that the diagram suggested that one of the angles, so we'd substitute x, 35 for all those values of x
right.
in the diagram. I don't know if we have the diagram here again.
So based on the diagram, I don't think we have the diagram. We should have had the diagram here, but nevertheless. So the question requires the values of all the angles. So we had
So this is what we'd have: 35, 35, 70, and 220.
And you can always check to confirm this. So,
Alright.
and remember our degrees. So 35 degrees, 70 degrees, and 220 degrees.
All right, so we're out of time for this lesson. I thank you so much for joining us today. Join us tomorrow for more CSEC mathematics. Until then,
Keep practicing and keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.